Hi Science 10. Real quick lesson today on 5.2 Kinetic Energy. This matches in your notes page 23 and 24. And we have a couple cool videos you can check out on the PowerPoint. But the definition of kinetic energy is the energy of motion. And so either if it's vibrational or rotational, any kind of motion is considered kinetic energy. So there were mentioned before, I know in grade 7 we talk about these four. There's four kinds of categories for energy. Today our topic is about kinetic energy, and there is a way to calculate that using speed and mass. It's got to be moving and it's got to go at a certain velocity. So kinetic energy in joules will be calculated by half m, which is mass, times velocity squared. So 1/2 mv squared, pretty easy. If something is getting squared, like if this value is 4, make sure you're going 4 times 4 when you calculate this, because it is velocity squared. Mass is always going to be in kilograms. Velocity is going to be in meters per second, but remember we're squaring both of those, so that's how we end up with a value for kinetic energy in joules, which is kilogram meter square per second square. So it all works out when you're looking at the units. This gets a little bit tricky when you have to change the formula around, and so you can't really go back to our old triangle method and make this simple. So you can use this as your calculation or equation to do your calculation for mass. It is going to be 2 times kinetic energy over velocity squared. If you're finding out velocity, you're going to have to do square root of 2 times kinetic energy over mass. So regularly, most of the time, you're going to get questions about just half mv squared for kinetic energy, but you may have to do calculations on these two other versions of the formula. If you like to mess around and manipulate formulas, you can see how we get those, derive those, but those are the 3 formulas that the 3 versions of the formula you will be using when you try the practice questions. So I'm just looking at this question, looking at 2 problems comparing this tennis ball versus the bowling ball. And so these are both worked out here. The tennis ball, remember, if you see kilometers per hour here, you've got to do the divide by 3.6 thing to get it in meters per second, so that you can actually use the half mv squared. We have the 1/2 times mass of our object that's got to be in kilograms, so you've got to change the grams to kilograms, and then you've got to change your kilometers per hour to meters per second, and remember there's a square on there. So to figure out the tennis ball thing, it is going to be 1/2 times your 0.0567 kilograms times your 69.17 that we calculated here, meters per second, and that is squared. So I'm just showing you have to square that 69.17. So when this goes in your calculator, you're going to do 0.0567 times 69.17 times 69.17, and then take half of that, so divide by 2, and that is going to be 136 for the tennis ball. When we do the bowling ball here, it's already in kilograms, so it's 1/2 times 7.39 times 6.02, because that's already in meters per second. But remember, it's squared, so you got to multiply it again by 6.02. Try that out in your calculator. You should get 134, so that you can check with these examples whether you can get the 136 over here and the 134 over here. Make sure that it's something you can calculate. See how your calculator works. Make sure that these are, because this does have that square in there, make sure these are calculations you can do. I have one more in here that's just an extra step, and for your homework practice questions, I don't have any 2-step questions in there like this. So this is actually there's one two-step question in your homework. So this is one that is kind of extra higher difficulty level, but it's definitely doable when you realize that you can use two equations that we've talked about so far in chapter 5. First of all, they are asking you about time, and to get time we can use our velocity formula of distance over time, or turn it around and say time will be determined by distance over velocity. But to get this velocity here, we have to get it from the other version of our half mv squared formula. So it would be, go back to the first page, and I showed you that you can get velocity by taking a square root of 2 times kinetic energy over mass. And we have all those values in this question about the curling rock. So we've got the 151.29 joules, we've got that. We've got our 18 kilogram rock. If you go 2 times the joules, divide by 18, take a square root of that, try that on your calculator, you're going to get the 4.1 meters per second velocity. And then you can pop that 4.1 right here and go distance that rock went. It said it was 45.72. And you can just divide that by the velocity, and that's how you get your answer, which I did post right here. But I'm showing you how you can get it using two formulas. And in order to get time, we know we have to get the velocity, and we can get the velocity by this this other manipulation of our formula that we just learned about. So to practice, we are going to work on the practice that is in your notes on page 25 and 26. That is giving you lots of practice on the different ways to turn around that that kinetic energy equals half mv squared formula. So when you're doing that, keep these different versions of that formula handy so that you can use whichever one you need for page 25, 26. And that will get you ready for the 5.1, that will get you ready for